Thermodynamics. Now, in thermodynamics, you first of all start with the first topic, that is basic terminology and concepts. Basic terminology. There are some basic terms that we have to discuss, and then we will move forward. Now, when we start with thermodynamics, then the first thing that we have to understand is what is system. We are going to study some particular part of a universe, and that part is known as the system. First term that you have to understand very clearly is what is a system. So system is, you can write with me, a specific part of universe which is under observation. Which is under observation. That is known as system. Now, when we start with system, first of all, then we can classify the system in two different categories. Now, just as you know, system starting and here only we can classify it into two different categories. System जो होते हैं दो किस्म के होंगे. You can either have a heterogeneous system or a homogeneous system. Now, write these things with me, okay? These are not very difficult concepts. You can write it with me. So you have heterogeneous system and you have homogeneous system. Now, the interesting part or the main part about heterogeneous system is that obviously a system will be made of more than one components, and all the components, if they have more than one state, like एक कोई liquid में, कोई solid में, कोई gas में है, if that type of system is present, जहाँ पे component अलग-अलग state में है ना, they are in different states, then we call it a heterogeneous system. So heterogeneous system is when you have components have more than one state. स्टेट जो है ना, यहाँ पे हम लोग एक और मीनिंग इस्तेमाल करने वाले हैं, इसमें हम मोर देन वन फेज लिख रहे हैं. सॉलिड फेज, लिक्विड फेज, ठीक है. फेज का मतलब स्टेट्स ऑफ मैटर वाला स्टेट्स, ठीक है. होमोजेनस में क्या होगा, द कंपोनेंट्स हैव ओनली वन फेज. या तो सारे के सारे लिक्विड है, या तो सारे के सारे सॉलिड है, या तो सारे के सारे गैस है, या तो सारे के सारे पानी में, या तो एक्वस फेज में. Now, for example, you can see, if I talk about boiling water, then it is going to be heterogeneous. Why? In boiling water, there will be liquid water as well as the water vapors. So liquid and solid, sorry, liquid and gas, both of them are present, right? So it is heterogeneous. And for example, if you have block of iron, this will be homogeneous because we have only iron, and that is what it is, one block. Similarly, if I take pencil, so pencil is also going to be what? It is going to be homogeneous because all the components inside a pencil is what? It is in solid. The wood part is also solid, and the lead or the graphite part, it is also solid. If I talk about human body, then human body is going to be heterogeneous because the skin is solid, the muscles are solid, the skeleton is solid, but the blood which we have, it is what? It is in liquid state. Then we are breathing also, so we are taking in air. So inside our lungs we have gas, so that is also going to be liquid. So that's also going to be gas. So यहाँ पे क्या हो जाएगा? Heterogeneous. Similarly, if I say glass of water, now this is also important, glass of water, ठीक है. So the glass of water, that means the glass and also the water which is present. So glass is solid and water is liquid, so it is also going to be hetero. Okay. Now, these are the some examples. After this, you are going to write, after system, you are going to write surrounding. The second thing that we have to understand is surrounding. Now, what is surrounding? Surrounding is the remaining part of the universe which is not part of the system, which is not part of the system. Okay, so for example, if we have this as the universe, this whole thing is universe, and this part is our system, then the whole remaining part is surrounding. System and surrounding, they combine to make the universe. Okay. Now we have another term, that is boundary. Boundary क्या है? Is boundary is that part, imaginary or real, which separates the system and surrounding. System और surrounding को जो separate करते हैं वही boundary है. ठीक है. So boundary को function के हिसाब से लिखा जाता है, that system and surrounding are separated by boundary. ठीक है. So boundary has been identified as the function. Now one point regarding boundary is that boundary can be real or it can be imaginary also. So let us suppose if we are talking, let us suppose कि हम अर्थ को एज अ सिस्टम लेके चल रहे हैं, वी आर ऑब्जर्विंग द अर्थ. इन अर्थ की ऐसी कोई खास बाउंड्री नहीं है, राइट? यू डोंट हैव एनी फिजिकल बाउंड्री अर्थ, एंड देन यू विल से ओके फाइन अर्थ यहाँ तक है एंड देन वी हैव स्पेस. So that boundary that we are saying that okay fine earth यहाँ तक है, that boundary is actually imaginary. There is nothing which is surrounding the whole earth and having a boundary kind of thing. ठीक है. But let us suppose if you are talking about a container in which we have different types of reactants, then that container is going to be the boundary between system and surrounding. ठीक है. Now, when we talk about boundary and on the basis of different types of boundary, we can have different types of system also. ठीक है. System now can be classified on the basis of the boundary that we are having. So system को तीन कैटेगरी में क्लासिफाई किया जा सकता है if I classify it with respect to the boundary that we are having. Just give me a second. Now, system can be an open system, can be a closed system, and it can be an isolated system. ठीक है. ओपन सिस्टम में क्या होगा? The property of open system is that, please write with me, transfer of matter and energy both can takes place. ठीक है. दोनों का ट्रांसफर हो सकता है. ट्रांसफर ऑफ matter and energy can take place between system and surrounding. ठीक है. अच्छा. In this particular case, if I talk about what type of boundary we are having, then we say that we have an open system. तो वहां पे बाउंड्री नहीं होती है. There is no boundary here. ठीक है. बाउंड्री एग्जैक्ट कोई बाउंड्री नहीं होती, इमेजिनरी बाउंड्री होती है. एग्जाम्पल इफ आई टॉक अबाउट, फॉर एग्जाम्पल इफ यू हैव ओपन बकेट. ठीक है. ओपन यूटेंसिल. All of these are example of what? All of these are example of open system. Now in closed system, what can happen? Transfer of energy or heat, है ना? Heat. Energy can be transferred in the form of heat, right? Transfer of energy or heat is possible. But transfer of matter is not possible. ठीक है. अब ऐसे केस का एग्जांपल है, फॉर एग्जांपल इफ यू हैव अ क्लोज्ड यूटेंसिल. ढक्कन अगर लगा हुआ है, देन ऑब्वियसली हीट का एक्सचेंज हो सकता है, बट मैटर का एक्सचेंज यहाँ पे नहीं हो सकता है. नाउ द बाउंड्री दैट वी यूज हियर, इट इज नोन एज डायाथर्मिक बाउंड्री, या इसको वॉल भी बोला जाता है. ठीक है. डायाथर्मिक वॉल और बाउंड्री. नाउ इन आइसोलेटेड सिस्टम व्हाट वुड हैपन? नाइदर एनर्जी nor matter can be transferred. Neither matter nor energy can be transferred. ठीक है. Now this type of, for example, if you have thermos flask, right, or vacuum flask that you can see, CWM vacuum flask. Now the wall that we have here, in this case, we call it adiabatic wall or boundary. ठीक है. Raise your hand if you're done writing. Please raise your hand once you're done writing. For Amna and Kodecha. Just waiting for Amna now. ठीक है. Next, we are going to write. Now we have defined system and everything. So the main part of thermodynamics is that we have to study about the change that is occurring. So initially you will have the system. There will be some particular system will be having some particular properties initially, and there will be some process will happen, and then finally it will be in some particular property. Just for example, बहुत छोटा सा example लेते हैं. For example, let's suppose we are having water which is in 25 degrees Celsius and we heated it. and then finally it became 100 degrees Celsius and it was started to boil. So there is a particular thing that we are, देखिए इनिशियली भी यहाँ पे आपके पास पानी है और यहाँ पे भी आपके पास पानी है, राइट? नाउ व्हाट इज चेंजिंग, बट बोथ ऑफ दीज आर वाटर, ठीक है? सो व्हेन यू आर गोइंग टू लुक एट इट, सो देखने से उतना खास शायद आपको कुछ पता ना चले, but when you are going to touch it, then you will see, okay, fine, this water initially it was something else, now it is something else. So there is some certain property of water which is changing. So is the mass changing? No. Is the volume changing? No. What is changing? The temperature is changing. So there are certain things that we have to use, certain properties that we have to use, which will be changing as we go from initial state to the final state. Now, the property which we use to define the state of a system are known as state variable. है ना, कि इनिशियल से फाइनल जाने के लिए हम कौन से स्टेट को चूज कर रहे हैं, दैट इज व्हाट, दैट इज स्टेट वेरिएबल. ठीक है, सो प्लीज राइट द हेडिंग स्टेट वेरिएबल. What is state variable? Those properties that define the state of a system are called state variables. Are called state variables. ठीक है, एक बहुत ही ना हम आपको छोटा सा एग्जांपल देके बताते हैं, लाइक हाउ इट इज गोइंग टू चेंज. फॉर एग्जांपल, लेट अस सपोज यू हैव टी और कॉफी, फाइन. टी और कॉफी थोड़ा सा गर्म है, तो इट इज एट 60 डिग्री सेल्सियस और यहाँ पे इट इज 250 ml, फाइन. नाउ लेट अस सपोज देयर आर टू डिफरेंट सिनेरियोस व्हिच आर हैपनिंग. ठीक है, एक क्या हुआ, आफ्टर 20 minutes, what you see here, you see here that the cup is here as it is, but the volume has increased. That means 300 ml हो चुका है, let's suppose, and the temperature has been reduced to 25 degrees Celsius. ठीक, उसी तरह से दूसरा कप यहाँ पे है. दूसरा सिनेरियो, आफ्टर 20 minutes you are seeing the cup with coffee or tea, whatever you like. Now what you see here, it is 100 ml. ठीक है, बट द वॉल्यूम हैज बीन डिक्रीज टू 100 ml. बट जो टेम्परेचर हो चुका है आपका, मान लीजिए लेट सपोज व्हाट 50 डिग्री और 45 डिग्री, राइट? 50 डिग्री सपोज 15 डिग्री सेल्सियस. और दोनों ही सिनेरियो में आपकी बहन आके गई है रूम से बाहर, ठीक है, योर ब्रदर और योर सिस्टर आपके रूम में आई और आपके रूम से वापस गई. नाउ इफ यू आर गोइंग टू ऑब्जर्व दिस, इन दोनों ही ऑब्जर्वेशन से यू कैन हैव डिफरेंट डिफरेंट दूसरे अलग अलग चीजें आप दे सकते हैं. क्या इससे आपको ये पता चलेगा कि शायद आपके बहन ने क्या किया, 25 डिग्री सेल्सियस हो गया 30 ml, शायद इसमें उन्होंने क्या किया, पानी डाल दिया, एडेड वाटर. तभी 250 से 300 ml हो गया है एंड द टेम्परेचर हैज डिक्रीज्ड बहुत ज्यादा, है ना, सिग्निफिकेंटली. इन दिस केस व्हाट यू विल से दैट आपकी बहन ने पी लिया पानी, शी ड्रैंक द टी और कॉफी. नाउ व्हाट आर द पैरामीटर्स दैट वी आर यूजिंग टू conclude these things? We are using what? Temperature, and we are using volume. यहां पे जो टी का कप होगा इसका कुछ मास भी होगा, है ना? टी का कप का कुछ इंग्रेडिएंट भी होगा, दैट टी में ये है, ये है, ये है. बट वी आर नॉट टॉकिंग अबाउट दोज थिंग्स. ठीक है, what we are talking about, we are talking about only what we are only talking about the 60 डिग्री सेल्सियस. ये कहाँ चला गया है, 25 डिग्री सेल्सियस, 60 डिग्री सेल्सियस से 50 डिग्री सेल्सियस, और ये यहाँ पे क्या हो गया, वॉल्यूम का चेंज आया. Now, if I go to the second case, the volume change is significant and we'll be focusing on the volume change and not on the temperature change. क्योंकि कम हो गया ना, तो पी लिया होगा. सेकेंड केस में हम किस पे फोकस करेंगे, वी विल टॉक अबाउट द टेम्परेचर चेंज, कि 25 डिग्री सेल्सियस कैसे हो गया, तो जरूर उसमें कुछ ठंडी चीज ऐड की है. Now, these are different things that we are observing. अब यहीं से आपके पास दो चीज आती है, which we call state function and path function. ठीक है, प्लीज राइट स्टेट फंक्शन. So what is a state function? State function, it depends only on depends only on the initial and final state. Initial and final state of the system. Second is path function. पाथ फंक्शन वो प्रॉपर्टीज होती हैं which depends on the way in which process was done. Just give me a second, please. Okay, sorry for that, guys. Now, state function and path function. So, state function depends only on the initial and final state of the system. Path function depends on the way in which the process was done. Then, next we have macroscopic properties. That means, please write macroscopic properties. Macroscopic properties क्या होती हैं? Like we have microscopic properties ना, that is atomic weight, bond length. These are microscopic properties है ना, atomic level पे. Macroscopic होती है bulk की properties. Properties of, please write, properties of bulk of a substance. एक एटम की या एक मॉलिक्यूल की प्रॉपर्टी नहीं. If I have million and millions of molecules, then we will have some kind of properties. For example, what are the examples we can have? We'll have mass, that will have volume, it will have temperature, it will have density, right? What else it can have? It can have boiling point, it can have melting point, etc. Now, macroscopic properties are classified into two different categories. एक होते हैं extensive और एक होते हैं intensive. ठीक है? So please write extensive properties. What are extensive properties? So extensive properties, they depends on the amount of or mass of substance. For example, मास ही को ले ले. अगर आप अमाउंट बढ़ाएंगे तो मास बढ़ेगा. Similarly, if you will increase the amount, then the volume of that substance will also increase. ठीक है. Number of moles, if you increase the amount, the number of moles will also increase, right? These are what? These are examples of extensive property. Then we have intensive property. Intensive properties. Intensive properties, it does not depend on the amount or mass of substance. For example, you have, let's suppose, temperature. ठीक, temperature होगी. No matter if you have, let's suppose आपके पास एक बहुत बड़ा टैंकर है. Tank, in this you have temperature 10 degrees Celsius. So if you remove a small portion and then measure the temperature will be still 10 degrees Celsius, right? temperature, then boiling point. Now, water boiling point is 100 degrees Celsius, no matter whether you are having 1 kg of water or 1000 liters of water. Similarly, you have melting point. It is also what? Intensive property. Density. Density of water is same, no matter if you take 1000 kg or 1 gram. Okay, so these are what? These are some examples of intensive property. Next, last concept that you have to write is regarding thermodynamic process. Thermodynamic process. What is thermodynamic process? Please write process which results in change of at least one state variable. At least one state variable अगर change हो जाए तो उसको thermodynamic process बोलते हैं. Now there are different thermodynamic process that we can have. Let's suppose if we have isothermal process. Isothermal process. Then in isothermal process, temperature does not change. Initially or finally temperature same रहेगा. Temperature remains constant. पूरे प्रोसेस में टेम्परेचर वही रहना चाहिए. Let us suppose B, you can have another type of process which is known as adiabatic process. Adiabatic process. Adiabatic. In this, there is no exchange of heat. No exchange of heat. यानी हीट की बात आएगी तो हीट के एक्सचेंज को बोलेंगे जीरो. Then C, we have isobaric process. In isobaric process, the pressure remains same. Pressure remains constant. D, you will write isochoric process. Isochoric process is when you have volume remains constant. And E is cyclic process. In cyclic process, what will happen? After there will be different types of process, एक process, दो process, तीन process, और end में आके it will return to the initial state. So in cyclic process, what happens? After various process, the system returns to initial state. System returns to initial state. Now, इसके बाद there are two more process जिसको हम लोग as a difference लेके चलेंगे and we will understand how they are different to each other. Please write this down. Raise your hand once you're done. Waiting for Amna. Amna just waiting for you. Next, we have the reversible and irreversible process. But in order to understand that, let's take an example. Take an example से समझिए इसको अच्छे से समझ में आएगा. Now let us suppose we have a sand bag, or there is a bag which is full of, let us suppose what, wheat grains. ठीक है, wheat grains मान लीजिए. ठीक है, this is fully stacked of wheat grains, and here we have a container, and then we have a movable piston. We have a movable piston, and I have to dump all the wheat grains that we are having onto this piston, and then this piston will go down. Now there are two different ways of doing it. One way is that I dump it all at once. I take the whole bag of wheat grains and I can dump it all, and then what will happen, this piston will go down, and we will have wheat grains here. It will be filled by wheat grains like this. This is one way of doing it. Or what I can do, it is completely not a natural way or a logical way of doing it, but the next way that I'm saying is what I can take. I can take one grain of wheat and I will put it here. And I will take another grain and I will put it in. Slowly, 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 I will be reaching this point. Does this make sense? But tell me, guys, does this make sense? Yes or no? Please tell me, guys. There are two ways of doing this process. This is really unreasonable. तो कोई समझाने का मकसद ही नहीं बचता, ना ही आप लोग कुछ जवाब दे रहे हैं. तो now there are two ways that, as we discussed. One way is to dump everything all at once, right? Dump all at once. And then what you can do, put one particle at a time. Now, when you are dumping all at once, why? As soon as you started to dump, no? As soon as you flipped that bag of wheat grains, you cannot stop the process. You cannot reverse that process. Please try to understand this part. It's very crucial. I am not saying that you cannot go from final state to initial state. That is not the meaning of reversible. Obviously, you can, like once you have dumped, you can take all the dumped thing and then you can put it in the sandbag also. That can be done. But while the process is happening, while it is getting dumped, you cannot stop it. Once everything has dumped, when the process is complete, then you can take another process and then you can re-dump it on the sandbag. But when you are dumping all at once, it is an irreversible process. The process is irreversible. You cannot stop the process in between. So, or rather, you cannot reverse the process in between also. So, what we will say, it is irreversible process. ऐसे process क्या बोलते हैं? Irreversible. Now, the next process that we took was We took one grain of one grain of wheat and I put it on the piston, another and I put it, another and I put it. Then what can happen? I can change the direction of process at any time, and I can change the direction. I have not, that process is not complete, right? If I, even if I am at this particular point, I can reverse it. So we can say that another process is what? Reversible process. Another type of process is going to be reversible process. Reversible process. Now, irreversible process, how to define it? Just make a line. Irreversible process. Process whose direction cannot be changed at any stage. Reversible process. Process whose direction can be changed at any stage. Now, next point you will write driving force is different than opposing force. You will write the driving force dF is only infinitesimally greater than opposing force. Next point. It is done rapidly. It is done in very small steps. Here, equilibrium is not maintained. Here, equilibrium is maintained at all stages. Irreversible process, all natural processes are irreversible. And reversible process is an imaginary process. It is an imaginary process. Write this down, raise your hand once you're done. Raise your hand once you're done writing. Please raise your hand once you're done. Waiting for Hamna. Hamna, just waiting for you. Right, next. Right, next, internal energy. यहाँ से बेसिकली आपका डेफिनेशन खत्म हो रहे हैं. इंटरनल एनर्जी चीज है जनरली थर्मोडायनेमिक्स. अब यहाँ से स्टार्ट हो रहा है. ठीक है, धीरे धीरे विल स्टार्ट अबाउट. जैसे एनर्जी की बात आ गई, यू विल हैव थर्मोडायनेमिक्स इज स्टार्टिंग नाउ. सो प्लीज राइट इंटरनल एनर्जी. It is denoted by U. Now, what is internal energy? It is sum of all forms of energy. Sum of all forms of energy. Sum of all forms of energy stored in a system. Stored in a system. Now, since it is sum of all forms of energy, it is very difficult to measure, or rather, it is impossible to measure the internal energy of a system. Because how can you measure all forms of energy? Now, this very set is very difficult to measure the internal energy. Please write, it is impossible to measure all forms of energy. Therefore, measurement of internal energy is impossible. Rather, we measure internal change in internal energy. Measure change in internal energy. Okay. So change in internal energy is given by delta U, which we say it is equal to U final minus U initial. Okay. This is definition of change in internal energy. It is not a formula. ठीक है, इसको ध्यान रखिएगा जरा. It's not a formula. Now, that means how can internal energy of a system change? ठीक है, तो उसके बारे में बात करेंगे. सो देर आर ओनली टू मोड्स ऑफ ट्रांसफर ऑफ एनर्जी. दो ही तरीके से आप एनर्जी ट्रांसफर कर सकते हैं फ्रॉम सिस्टम टू सराउंडिंग, सराउंडिंग टू सिस्टम. उसके बारे में बाद में बात करेंगे, बट देर आर टू मोड्स ऑफ ट्रांसफर. ठीक है, सो यू राइट द हेडिंग मोड्स ऑफ ट्रांसफर ऑफ एनर्जी. मोड्स ऑफ ट्रांसफर ऑफ एनर्जी. ठीक है, प्लीज राइट हियर. व्हाट आर द टू मोड्स ऑफ ट्रांसफर? पहले आपके पास हीट. आप किसी बॉडी को हीट कीजिए तो क्या होगा? द एनर्जी विल इंक्रीज, राइट? सो हीट में आप दो चीज कर सकते हैं. व्हाट यू कैन डू, यू कैन ऐड हीट टू द सिस्टम. तो यहां पे हम लोग क्या करेंगे, क्यू को लेंगे पॉजिटिव, यानी कि एनर्जी जो है ना उसकी बढ़ रही है, तो क्यू को कैसा लेंगे, पॉजिटिव लेंगे. बिकॉज वी आर, हीट कहां से कहां जा रहा है, सराउंडिंग से सिस्टम जा रहा है. सिस्टम को चीजें मिल रही है, दैट मीन्स पॉजिटिव. व्हाट यू कैन डू, यू कैन टेक हीट अवे फ्रॉम द सिस्टम. है ना, आप कहां से कहां कर दे, सिस्टम से सराउंडिंग को हीट दे दे. दैट कैन ऑल्सो बी डन ना. सो व्हाट यू विल राइट, टेक हीट फ्रॉम सिस्टम. तो यहाँ पे एनर्जी कम होगी, तो इसको कैसे, क्यूब जो होगा हमारे पास, इसकी जो हम लोग साइन लेंगे दैट विल बी नेगेटिव. हियर द ट्रांसफर इज गोइंग कहां से कहां, सिस्टम से सराउंडिंग में हीट जा रहा है. नेक्स्ट पॉइंट है आपके पास वर्क. वर्क इज गिवन बाय डब्ल्यू. वर्क भी दो तरीके से हो सकता है. वर्क कैन बी डन ऑन द सिस्टम. वर्क डन ऑन द सिस्टम, दैट विल बी पॉजिटिव. और जब वर्क इज डन बाय द सिस्टम, सिस्टम अगर काम करेगा, वर्क डन बाय द सिस्टम, इन दैट केस वर्क विल बी, उसको हम नेगेटिव लेंगे, बिकॉज सिस्टम की एनर्जी कम होती जाएगी. नाउ रिगार्डिंग दिस पर्टिकुलर इंटरनल एनर्जी, हीट और वर्क, ये दोनों मोड ऑफ ट्रांसफर ऑफ हीट के हिसाब से देर इज फर्स्ट लॉ ऑफ थर्मोडाइनमिक्स. फर्स्ट लॉ ऑफ थर्मोडाइनमिक्स, इसको बोलते हैं फ्लॉट. फर्स्ट लॉ ऑफ थर्मोडाइनमिक्स. फर्स्ट लॉ ऑफ थर्मोडाइनमिक्स जो स्टेटमेंट है बहुत ही सिंपल है. says that in an isolated system, in an isolated system, the energy of system is constant. मतलब कि अगर आइसोलेटेड सिस्टम है तो एनर्जी ऑफ सिस्टम विल बी कांस्टेंट. व्हाट डज इट मीन, इट मींस दैट बिकॉज इट इज आइसोलेटेड सिस्टम, वहां पे आपके पास ना ही हीट आ सकता है ना ही वर्क आ सकता है. दैट इज वाई द इंटरनल एनर्जी ऑफ सिस्टम इज नॉट गोइंग टू चेंज. बेसिकली it wants to say that the internal energy of system can only be changed when you add heat or work to it. This is the mathematical form. आपके स्टेटमेंट में कहीं पे भी ना हीट आ रहा है ना वर्क आ रहा है, बट इन मैथमेटिकल फॉर्म यू हैव बोथ heat and work. Why? Because as soon as they said isolated system, it means that they are saying that heat नहीं आ सकता है ना इस पे कुछ वर्क किया जा सकता है. That is why the energy of system is constant. ठीक है, so they are indirectly telling you about the two modes of transfer of energy, heat and work. Please write this down. After this, you please see this question. In this question, they are asking, express the change in internal energy of the system when no heat is absorbed by the system from surrounding. That means पहले वाले सवाल में क्या है? The first question they are saying Q is equal to 0, but work is done on the system. वर्क इज डन ऑन द सिस्टम यानी कि वर्क को कैसा लेना है? पॉजिटिव लेना है. ठीक है. एक एक्सप्रेस द चेंज. ठीक है. तो एक्सचेंज को कैसे एक्सप्रेस करेंगे? डेल्टा यू इट इज इक्वल टू क्यू प्लस डब्ल्यू. क्यू तो 0 है, डब्ल्यू है, तो डेल्टा यू विल बी इक्वल टू वॉट एवर वर्क इज डन, उसी का वैल्यू, पॉजिटिव वैल्यू ना जो है वही. And then they are saying what type of wall does the system have? Then since no heat is absorbed, so when there is no transfer of heat, then the wall की अगर हम बात करें तो wall is going to be adiabatic. Adiabatic. Secondly, they are saying no work is done on the system. That means W it is equal to 0. But Q amount of heat is taken out from the system. हीट जो है वो बाहर निकल रहा है, तो हीट को क्या लेंगे? नेगेटिव लेंगे. एंड गिवन टू द सराउंडिंग, तो हीट वहां से निकल रहा है. सो व्हाट विल बी द चेंज इन इंटरनल एनर्जी? डेल्टा यू जो होगा इट विल बी इक्वल टू वट एवर हीट इज रिमूव, उसका नेगेटिव, तो माइनस क्यू. अगर 120 जूल आपने एनर्जी दी है सराउंडिंग को, इफ यू आर गिविंग 120 जूल ऑफ एनर्जी फ्रॉम सिस्टम टू सराउंडिंग, द चेंज इन इंटरनल एनर्जी विल बी माइनस 120 जूल. If I talk about the wall, what type of wall is present? Since work is not done, यहाँ पे diathermic wall बोल सकते हैं because heat का exchange हो रहा है. Here we are having diathermic wall. This sorry. The C case they are saying W amount of work is done by the system and Q amount of heat is supplied to the system. यानी कि थर्ड केस में वर्क भी हम लोग वर्क इज डन बाय द सिस्टम, दैट मीन्स माइनस डब्ल्यू, है ना. वर्क को कैसा लेना है? नेगेटिव लेना है वर्क को. वाई? बिकॉज वर्क इज डन बाय द सिस्टम एंड क्यू अमाउंट ऑफ हीट इज सप्लाइड टू द सिस्टम. क्यू को लेना है पॉजिटिव बिकॉज आप सिस्टम पे हीट दे रहे हैं. सो वी कैन से दैट डेल्टा यू इज गोइंग टू बी इक्वल टू क्यू माइनस डब्ल्यू. एंड इफ आई टॉक अबाउट द वॉल इज गोइंग टू बी अ क्लोज्ड वॉल बिकॉज यहाँ पे मैटर की नहीं, मैटर की एक्सचेंज की बात नहीं की जा रही. प्लीज राइट दिस डाउन. रेज योर हैंड वंस यू आर डन. Amna and Khadija, raise your hand once you're done. You just write this as problem 6.1. This is in NCERT, okay? So आप इसको लिख लीजिए problem 6.1 NCERT and these are the answers. Just waiting for Khadija now. Okay. After this, please write a question. Write the question like this. A system absorbs 428 joule of heat and does work equivalent to 286 joule on its surrounding. Determine the internal energy change in the process. बहुत आसान सवाल है. You can send the answer on the Zoom chat. आई विल गिव यू गाइस 3 मिनट्स फॉर दिस, 3 मिनट्स इज मोर देन एनफ। आराम से सवाल को लिख के और आंसर बताइए। Yes. No, very good. That is correct. So here it is saying system absorbs 420 joule of heat. That means Q जो होगा आपका absorbs कर रहा है. That means Q will be positive. तो Q का जो sign है वही लेना है ना. Will be 428 joules. Then it is saying does work. The system is doing the work. तो work को कैसा लेना? Negative लेना. तो work will be equal to 286 joules with a minus sign. And delta U, it is equal to Q plus W, whatever will be the values. Q की value क्या है? 428 minus sorry plus work की value है minus 286 and 428 plus minus will be minus 286. 8 minus 6 is going to be 2 and 42 minus 28 is going to be 14. ठीक है, so 142 joules of energy, that is the internal energy change. राइट दिस डाउन खदीजा, ये आसान था, करना चाहिए आपको, आप पता नहीं क्यों इंगेज ही नहीं करते क्लास में। Raise your hand once you're done, Khadija. Khadija, waiting for you. Please raise your hand once you're done. Okay. Now please write. There's a formula for work that you have to remember, that work can also be written as minus of P external into delta V. This is known as pressure volume work. क्या मतलब प्रेशर वॉल्यूम वर्क का? फॉर एग्जांपल, इफ यू हैव अ कंटेनर लाइक दिस, ठीक है, इस तरह से आपके पास एक कंटेनर है, एंड देन इन दिस कंटेनर लेट अस सपोज we have a movable piston, and then in this piston we are applying some pressure, and this piston is moving till here. So this is the length that it is covering, or this is obviously is going to be 3D, so you can assume that this piston is having a circular base. तो वो जो circular base होगा, that will be the area, and the volume change that we can say, it is what the volume of a cylinder is, what the area of base into the height. तो जो यहाँ पे डेल्टा V होगा, डेल्टा V it is going to be equal to A into L, the area that we are having into L. अच्छा, अब प्रेशर जो होता है, प्रेशर क्या होता है? प्रेशर इट इज इक्वल टू व्हाट? फोर्स अपॉन एरिया, फोर्स अपॉन एरिया, ठीक है। फोर्स अपॉन एरिया, तो फोर्स क्या होता है? फोर्स इट इज इक्वल टू प्रेशर इनटू एरिया, ठीक है। फोर्स इज इक्वल टू प्रेशर इनटू एरिया। नाउ व्हाट इज वर्क? वर्क इज इक्वल टू फोर्स इनटू डिस्प्लेसमेंट, एफ इनटू डी, ठीक है भाई। अब फोर्स क्या होता है? फोर्स वी हैव रिटन एज प्रेशर इनटू एरिया, ओके। एंड व्हाट इज डी? डी इज दिस डिस्प्लेसमेंट, यहां से यहां तक ना, एक आपने फोर्स लगाया, उस फोर्स से इतना मूव किया, तो डी इज एक्चुअली ए, डी इज एक्चुअली एल। Now this is equal to pressure into A into L. What is A into L? It is delta V. Now since we are using the external pressure, we have to put up a minus sign, and that is why we have work done. It is equal to minus P external delta V. Okay, so please write this down. You can write this as a heading: pressure volume work. I'm not just waiting for you. If you're done, please write a question. A gas absorbs Okay. A gas absorbs 120 joule of heat and expands against external pressure of 1.10 atm from a volume of 500 ml to 2 liters. What is the internal energy change? Internal energy change in the process. ठीक है, सी है फर्स्ट ऑफ ऑल यहाँ पे आपके पास क्या दिया हुआ है, they have given you guys the gas absorbs itna joule of heat. So since it is absorbing 120 joule of heat, that means we have to take Q as positive, that is equal to 120 joules. And it is saying expands against the pressure of 1.10 atm. अगर हम वर्क की बात करें, which is equal to minus P external into delta V. The P external is, with the minus sign will be here as it is, 1.10, 1.1 multiplied by change in volume. Volume क्या होगा, फाइनल से इनिशियल, तो फाइनल वॉल्यूम इज 2 liters. दैट मींस मल्टीप्लाइड बाय 2 liters minus 500 ml. So I will convert this to liter, it will be equal to 0.5 liters. So I can write this as minus 1.1 multiplied by 2 minus 0.5 will be equal to 1.5. ठीक है, नाउ 1.5 into 1.1, तो 15 into 1 कर सकते हैं ना, तो 15 and 15 165, and there are two decimal points, so 1.65. This will be equal to minus 1.65. Now if you look at the units here, the pressure is given in the terms of atm, volume is given in terms of liter. तो आपको मिल रहा है वर्क इट इज इक्वल टू लीटर एटीएम. यहाँ पे एक चीज आप लोग ध्यान रखिएगा, वन कन्वर्जन दैट यू शुड रिमेंबर इज 1 लीटर एटीएम. जो लीटर एटीएम होता है दैट इज अप्रोक्सीमेटली इक्वल टू 100 जूल्स. ठीक है, तो यू कैन से दैट दिस इज इक्वल टू माइनस 1.65. लीटर एटीएम की जगह क्या लिख सकते हैं, 100 जूल्स. So this will be equal to 165 joules with a minus sign, that is work done. Now, what is the complete change in internal energy? So, delta U, it is delta U, it is equal to Q plus W. Q, it is equal to 120 joules plus minus 165 joule. ठीक है, so this will be equal to 120 minus 165. This will be equal to how much? Minus 45 joules. ठीक है, so this is how you are going to do the problems. इसको बहुत अच्छे से याद रखिएगा. 1 liter ATM, it is equal to 100 joules. Please copy this. Raise your hand once you're done. I'm just waiting for you now.